Hey students, today our topic is Fourier series. We have the question: find the Fourier series of the function f of x of period p is equal to 2l, and the function is f of x is equal to minus 1, which ranges from minus 2 to 0, and f of x is equal to 1, ranging from 0 to 2, where p is equal to 4. Or the question could be written in the form of function like this: minus 1 ranges from minus 2 to 0, and 1 from 0 to 2, where p is equal to 4. Now we have to find the Fourier series of this function. So first of all, there are 3 steps to solve this question. First of all, we have to find the values of a naught, secondly a n, and the thirdly b n. Okay, now it is given in the question that p is equal to 12. So p is equal to 12. Now we have to find the value of l, as p is equal to 4 given in the question. So we get the value of l is equal to 2. Okay, now we have to find the value of a naught, whose formula is 1 by 2l integral minus l to l f of x d of x. Well, as l is equal to 2, so in the place of l I put 2, and in the place of minus l I put minus 2, and l I put 2. Okay, f of x d of x. As given in the question that minus 1, our function has two integrals. First is minus 1 and second is 1. First integral has range is minus 2 to 0, and second from 0 to 2. So I apply the two functions as minus 2 to 0, our first function, and 0 to 2, our second function as well. Our first function is minus 1 and second function is 1. Range is minus 2 to 0, minus 2 to 0, 0 to 2, like 0 to 2. Well, now I apply the integral. In the place of minus 1 I get minus x, and the limits are applied. In place of 1 x, limit 0 to 2. Well, now we have to apply these limits. Okay, so 0 minus minus 2 plus 2 minus 0. Well, now we have to solve it, and I get so the value of a naught is equal to 0. Okay, now we have to find the value of a naught. As l is equal to 2, and our two functions that are minus 1 and 1, and a n is equal to 1 by l integral minus l to l f of x cos n pi x divided by capital L into d of x. So in the place of l I put 2, and in the place of function, our first function is ranging from minus 2 to 0, minus 1 cos n pi x over capital L d of x, plus our second function is ranging from 0 to 2, and our function is 1 cos n pi x over L into d of x. Okay, now 1 by 2, we have to apply the minus sign and the plus sign, and we get minus 2 to 0 minus cos of n pi x over capital L to d of x plus 0 to 2 cos n pi x over capital L d of x with the bracket close. Okay, All of us know that the integral of cos of x is equal to my plus sine of x. So it is equal to 1 by 2 minus sine n pi x over capital L divided by n pi over L, and the range is minus 2 to 0, plus sine n pi x over L divided by n pi L, and range is from 0 to 2 respectively. Now n pi divided by L and n pi divided by capital L is common. Okay, in the place of sine of 0 minus sine of n pi, in the place of x I put minus 2, and in the place of L I put 2. Well, plus sine of n pi 2 by 2 minus sine of 0. As we all know that sine of 0 is equal to 0. So this could approximated as 0. These values are subtracted and this is equal to 0. So again we get a n is equal to 1 by 2 L by n pi into 0, where a n is equal to 0. Okay, now there is a third part of our question, that is to find the value of b of n. Okay students, now there is the third part of question that solve the value of b of n. b of n is equal to 1 by capital L integral minus L to L f of x sine of n pi x over capital L into d of x. Now in the place of capital L I put 2 and my function in this way. Okay students, now I have to apply these signs minus and 1. So we get minus 2 to 0 minus sine n pi x over L d of x plus 0 to 2 integral limit sine of n pi x over capital L into d of x. Well, 1 by 2, as we know that the integral of sine of x d of x is equal to cos of x, minus cos of x. So I get minus cos n pi x over capital L divided by n pi by L, and over limit is this. Okay, as plus minus cos of n pi x over capital L divided by n pi by L, which is from 0 to 2. Okay, well, now L over n pi is taking as common, and we get cos n pi x. In the place of L I put 2, change it from minus 2 to 0, minus cos n pi x by 2, ranges from 0 to 2. Well, now we have to apply the limit 1 by 2 L over n pi and cos of 0 minus cos of minus n pi the same way, cos of n pi minus cos of 0. Well, now we get 1 by 2, 1 over n pi. In the place of 0 I put 1, cos of 0 is equal to 1, minus cos of n pi minus cos of n pi plus 1, as 1 over n pi L. 2 minus 2 cos of n pi. Now we have to take the 2 as common, so I get 1 minus cos of n pi. 2 is cancelled and we get L over n pi into 1 minus cos of n pi. Okay, this is the time to end up your question, and in the place of a naught I simply put 0. This is basically the formula of Fourier series. N is equal to 1 to infinity. In the place of an I put the 0, and in the place of bn I put L pi n pi into 1 minus cos n pi sine n pi by x over. In the place of capital L I put 2. Well, what we get now? We get our answer as, or over Fourier series as, L by n pi 1 minus cos of n pi into sine of n pi x by